We started building the team actually when COVID started. So I don't know, fortunately or unfortunately, I guess, our team is remote and it's all over the world. It's great in the sense that we can provide customer support 24 hours around. And it's bad because it's also like additional friction to synchronize with the team. Not only as a startup, we have to figure out how to grow and how to build the business on top of it, but we also should figure out and explore the technology itself. How do you imagine people are going to store all this unstructured data that's generated today and in future? My name is Davit Buniatyan, and I'm the founding CEO of Activeloop.
This is Code Story, a podcast bringing you interviews with tech visionaries who share in the critical moments of what it takes to change an industry and build and lead a team that has your back. I'm your host, Noah Lappart, and today how Davit Buniatyan decided to stop fighting large data sets and make machine learning companies more efficient. All this and more on Code Story. Davit Buniatyan is originally from Armenia. He completed his high school years there until he was 17 when he started to pursue his undergrad in the UK at UCL. He entered into his college years excited about animation from seeing Pixar movies. He learned all about 3D models, graphics, and rendering, but then found out there was no course or curriculum specifically for animation. So he switched to comp sci, which actually ended up being perfect. He's into swimming, tennis, and shotokan, I think I'm saying that right, which is traditional Japanese karate. Along with these, he's been playing chess since he was 5 years old and is an avid fan of the show Queen's Gambit on Netflix. When he started in on his PhD at Princeton, he started working with large data sets to recreate neural networks. In doing so, he realized how much computational power was required to learn from even a small, large-scale data set. With this, he set out to build a tool to make companies more efficient at learning from their data. This is the creation story of Activeloop.
So Activeloop helps machine learning companies to be more efficient when they have a lot of data. The product currently, we open sourced a dataset management tool that helps to represent any data, especially when it's unstructured, into a unified format that helps to do efficient machine learning. To give some motivation, when I got into my PhD, I got into a Princeton University lab at neuroscience department, led by my advisor, Sebastian Song. What they were working on is a field called connectomics, where the goal is to take a piece of mouse brain and reconstruct the connectivity of the neural networks. We were using artificial neural networks to be able to reconstruct the real neural network graph inside a small part of the mouse brain. But if you look into this small part, it's actually the data to represent that small part is huge. We have been storing up to petabyte scale datasets on the cloud and use deep learning on top to be able to reconstruct the connectivity of those neurons. And it was costing a lot of computational and storage effort to do that. And that inspired us to start the company basically thinking how we can help other machine learning companies to be more efficient. And one of the initial considerations that we had to rethink is actually how do you store the data? We had very good software engineers at our lab, William and Ignacio, who were working on this project called Cloud Volume, which was basically helping to represent biomedical data as chunked arrays on the cloud. So when data scientist was interfacing this data set, they were feeling it's like a local variable or local array they can work with. We thought that we can actually bring this to not only to biomedical imaging, but also to other domains like self-driving cars or aerial images like satellite imagery. Like why not to go into video, audio, text, and so on. So that's how we kind of came up with bringing this to the full extent where we can represent any data in the new format where you don't have to worry anymore about the files, where they are located, stored, versioned, and we call it like data 2.0. The kind of inspiration is coming from software 2.0. I guess you have heard about when machine learning models or deep learning models are taking over the usual code, when instead before programmers have to write all these instructions, now they actually are preparing the data, but they're training those models. So they're training those models to build the instruction set, and that's what's called software 2.0. But one of the missing components that we saw is actually the data. So how to prepare this data, how to version it, clean it, basically build it so that you can have efficient software 2.0.
This episode is sponsored by Vanta. You're a startup founder. Finding product market fit is probably your number one priority. But to land bigger customers, you also need security compliance. And obtaining your SOC 2 or ISO 27001 certification can open those big doors. But they take time and energy pulling you away from building and shipping. And that's where Vanta comes in. Vanta is the all-in-one compliance solution helping startups like yours get audit ready and build a strong security foundation quickly and painlessly. How, you ask? Vanta automates the manual security tasks that slow you down, helping you streamline your audit. And the platform connects you with trusted VCSOs to build your program, auditors to get you through audits quickly, and a marketplace for essentials like pen testing. Join over 8,000 companies, including many Y Combinator and Techstars startups who trust Vanta. Simplify compliance and get $1,000 off at vanta.com/codestory. That's VANTA.com/codestory. Well, tell me about the MVP. Tell me about how long it took to build and what sort of tools you used to bring it to life.
When we started the company, we got into Y Combinator, and one of the initial ideas, of course, we learned is that we have to launch as soon as possible. The initial idea that we had in the beginning was actually less about the storage and more about the compute. And that time we were thinking about, okay, so cool, we can take and distribute the machine learning compute to this crypto mining GPUs that were doing just wasteful computation, and they can do a useful computation here for the users to train their or deploy their models. And the tech stack that we have been using for that MVP was obviously we were using Python. Python is the best fit for machine learning those days, even though it's not super efficient when you are doing high performance computing. On the other hand, we also had to bring this whole kind of environment that the users decided to the remote computer. And of course, we were using Docker technology to do that. One of the things that we learned from this iteration is that this missing component is actually not the tech stack or the tools they are missing. It's more about the data. How do you transfer huge data from one location to the other location? And that's how our second MVP had been born, which we call it Hub. It helps data scientists basically to represent any data anywhere in any location. And behind the scenes, it sits on top of clouds, or it can also sit on top of the file system and helps to basically chunk the data set you have and store it on a local machine.
So with an MVP, and you mentioned two MVPs, with any MVP, you've got to make certain decisions and trade-offs when you're building them in the short term to essentially get it out there. What decisions and trade-offs did you have to make as you're building Activeloop and both of these MVPs, and how did you cope with those decisions?
One of the challenges is to cut down the vision that we have into a set of features that are very well optimized and performant to build an infrastructure there. This is like an infrastructure tool. You have to be very careful what you're pushing forward. One of the things that we cared more is actually, can we come up with a good API or good interface that the data scientists can enjoy working with? We always knew that we can do optimizations and quick performance checks behind the scenes because our initial prototypes had all those ticks there. But we decided to sacrifice in the beginning the speed and performance versus getting the product out, getting it to the user hands. Because one of the reasons that, hey, actually we can build the most performant data transfer or data storage service, but will the users need it or will the users use it? So I think we just prioritized the first hypothesis is, given the abstraction that we have about the data, can we make sure that users will enjoy and like the interface they're using to store and unify their data format in the beginning? We got a lot of traction on Reddit and a lot of feedback from the users. We got a lot of community as well. The people started joining our Slack channel and ask a bunch of questions. And then we felt, okay, now is the time to actually go and focus on optimizations and benchmarking to make sure that the code is performant and robust.
This episode is sponsored by Kinsta. Between juggling client meetings, managing your website, and keeping up with everyday tasks, who has the time to stress out about website security? Well, with Kinsta, the technical stuff is taken care of, so you can focus on what you do best. Kinsta provides managed hosting for WordPress, offering lightning-fast load times, top-tier security, and unmatched human-only customer support. Whether you're a business owner, web developer, or running a digital agency, Kinsta makes managing your website easy and efficient. Kinsta provides enterprise-grade security, being one of the few hosting providers for WordPress with SOC 2 and other certifications, guaranteeing the highest level of security for your website. Thanks to their unlimited free expert-led migrations, Kinsta ensures a smooth transition for you from other hosting providers. Customers have reported 200% faster load times post-migration to their platform. What I find cool about Kinsta is their fast and reliable customer service and premium features that are included at no extra cost. Ready to experience Kinsta's hosting for yourself? Get your first month free when you sign up at kinsta.com today. That's KINSTA.com. So, how are you planning to progress the product? And what I'm looking for in that question is how do you build your roadmap? What are the factors you're using to decide this is the next most important thing to build, to optimize, to form fit to our market's needs? How are you building that roadmap?
Well, the basic answer is the community or the users. If you look into the companies who have like open core go-to-market strategy, meaning they open source their core technology, and they might have various goals. Like one of the goals that we had initially is to get more users and traction to be able to use the piece of tool that we have been very passionate about and we're developing it. In the beginning, you have your own kind of biases to be able to get a direction. Let's say one of the biases that we had is that there is a lot of open source computing, machine learning based frameworks like TensorFlow, PyTorch. There are a lot of companies who are doing, let's say, annotations, but there is a missing component, missing gap between, which is we annotate the data and then we also can train very well, but what do we do in between those steps? And that includes building the data, storing it, like building the data pipelines, and then streaming this to the training process. So we thought, we have this kind of an initial idea, we are going to this direction, we are trying to be the best here, and then what? So we built the initial kind of ideas that we had in our mind that might be useful for the users, and then we decided to quickly launch it. With launching, I don't mean like do a press release or a big launch. We just collected 20 people into a webinar and then demonstrated what we are working on and see their feedback. And people got excited. And the same happened we did a couple webinars over the last period of 3 months, both our own, we got also invites for some other co-webinars in data science communities. Gathering all this feedback and iterating over the product, we actually came to a release version 1 and we launched it on Reddit and we got a huge growth. I think we ended up second in machine learning community that day, which has around 1.5 million members. And then starting from there, what we are focusing really is harnessing the user feedback, learning what are the user needs from the way they use the product. And the best way is actually talking to them and getting their feedback on things like, this part is slow. We get it back to them, let's say in a day or two with a fix and say, this is done. One of the core things that we learned is very important and we learned in a hard way is actually you should be very speedy in terms of reply rate to your users. So maximum, let's say if you can reply to 5 to 10 minutes and then get with a solution that you can't solve it in place, in a day or two. And that really differentiates you from others and the community really recognizes this. In return, they are happy to give you the feedback. And what you're looking for is you want to add your biases or your vision, the user feedback is kind of priceless.
Let's switch over a bit to team. Tell me about how you built your team and what you looked for in those people to indicate that they were the winning horses to join you.
Well, we started building the team actually when COVID started. So I don't know, fortunately or unfortunately, I guess, our team is remote and it's all over the world. We have people in Czech Republic, in India, also in Armenia, in Taiwan, in US. And we have a team that works 24 hours. It's great in the sense that we can provide customer support or user support 24 hours around. And it's bad because it's also like additional friction to synchronize with the team. To get to the answer, since we are building the team remotely at this point, and we all would love to actually go back to like into a single office where all of us are together, I think one of the important things is we should see that if there's a culture field in terms of the vision we are working with, this number one thing that me and Mikhail, who is heading the marketing and hiring efforts and also growth efforts, especially on the open source side, is that if we can actually be working on the same vision together, despite there's not that much of a good way to have an in-person interview. Then another issue or kind of feature we are looking for is the technological capabilities. If this person can actually independently solve the problem, which you might not find on the internet or not find any clue or solution, because we are like working on some stuff that is only very few people are working, and it's good and bad, and both sides you can argue, but the challenge here is that if you get stuck on a single problem, it's not like you can go into Stack Overflow and find the solution to this problem. Sometimes you are looking for creative and independent people who can try various experiments to identify what's the solution for the current problem. And sometimes you might not find the solution, so you need to figure out what is the best way to overcome this temporarily until a solution can be found out.
So it sounds like, with the solution you're building, you're pioneering the way. You can't just, Google it or Stack Overflow it to find the answer. So you need people that are willing to essentially go on that expedition with you. Is that right?
Yeah, exactly. And in some sense, it becomes also kind of a research problem. Not only as a startup, we have to figure out kind of how to grow and how to build the business on top of it, but we also should figure out and explore the technology itself and do a kind of a technical innovation. How do you imagine people are going to store all this like unstructured data that's generated today, and in future when you will have 5G, you'll have a lot of IoT devices, a lot of camera and sensors collecting all this various information and storing it somewhere. You have all this legacy you're getting from 20 or 30 years ago, but that's not enough and not optimized, not good for the current trends for doing machine learning on top. And sometimes those answers are also not trivial as well, neither for the data scientists or like developers who are working on it, and nor for us. Yeah, there's a lot of kind of exploration is required. So curiosity is number one thing. Besides of everything else, I'll say the standard thing is that user obsession. So if we come up with the best technology but nobody uses it, I think it's a big failure. So we should be user obsessed. Then technology obsessed, meaning like have this curiosity component. And the third is to be able to independently be responsible to manage themselves and others and take care of them, since given the remote settings that we are at, to be able to be efficient. And we haven't been efficient from day zero. So we are learning this how to be more efficient over the whole COVID period.
Did you build this to scale efficiently out of the gate? Or are you going to be fighting this as you grow? And it's going to be interesting to think about that from a machine learning related tool like you've built. How have you approached that problem of scalability?
Scalability boils down to the basic assumptions you have about the product and how it is going to work. And we feel that the assumptions that we initially took are a pretty good one for working with petabyte scale datasets. Let's say you have a lot of images and you have files. I don't know, have you ever experienced, let's say you want to send let's say 100 images to your friend using Messenger. Isn't it quite slow? And this is a fundamental problem. Like if you look into 100 images and each of them are 1 megabyte, then just transferring 100 megabytes should not be a problem with today's Wi-Fi and internet connectivity and so on. Sometimes the bottleneck is not actually on the network or the physical laws. It's actually the way we park the data and stream to other places. What we do if you take this, like let's say you have 100 images, instead of storing them and treating them as a single image, we actually combine them into a single tensor, we call it, which is has 100 samples, and each of, like let's say your images are full HD, so representing this as a single tensor. when the user interacts with it, it doesn't care it's like it's actually the first image or the last image, or the first file or the last file. It's actually, for him, it's like a single variable inside the code, like a NumPy array that he can interact with. Behind the scenes, what we do is actually we take these 100 images, we chunk them into small pieces. Let's say each chunk could be like 10 images, and we can store it in any location on your local cache inside the memory. We can store it on the file system, or we can store it on a remote object storage. The way we chunk this data and the way we treat data as like all the unstructured data sets, and not only unstructured, but also like one of the like advances we did compared to other open source tools, like we are not the only one, that we can also represent semi-structured data sets into this tensorial form, which helps you basically go like storing structured data as tensors is like pretty trivial, and the unstructured data is also like sort of fine. And once we also additionally have the semi-structured data sets, we are able to represent petabyte scale data sets on any location. And when I say here petabyte scale, what I mean here is that you have, let's say, 100,000 or million or 10 millions of images, treating them as a single object, which you can access any chunk of it or any part of it, and then stream this to the compute machine to be able to do the processing there. So before that, you had the Hadoop ecosystem or MapReduce based systems where you had this assumption saying that, okay, the network is the bottleneck, and we want pieces of the data to each compute machine and then keep there and then move the compute there to run the compute. But now, since the network connectivity got a huge boost, now you can actually, instead of presetting the data to the machines, you can actually store it in a centralized location, but still this location should be physically near to the compute machines, and give an access to all those virtual machines to have access to it. So what we allow to the virtual machine be able to do is, like, instead of storing, let's say, 100 gigabyte data locally on the machine, it can have a view of petabyte scale dataset from an object storage and stream any part of it to the GPU as fast as if the data was local to the machine. Given the object storage capabilities here, is that you know that there's some latency issue, there's a network overhead as well. The way we chunk the data, the way we compress the data, and the way we store this data on a centralized storage basically fine-tunes the current network infrastructure to be able to utilize at maximum speed the connectivity and bring this data to any machine on demand as if it was local. And there's one nuance there as well, is that we have to kind of know the pattern, how you are going to access the data. And when you're doing the training or you're doing inference using deep learning models, it's pretty standard, and you fetch the data one by one, and you know the pattern, how you are doing that. And it could be randomized access, but you still have the locations. And having this kind of assumptions, and given the data infrastructure, plus that the connectivity is getting very speedy compared to the compute, and also the compute is also changing as well with the recent innovations. We have been able to disrupt this notion of, okay, your data should be pre-baked to compute machines to run the compute, and now it can be stored in a centralized location and streamed on demand to run the compute in real time.
Well, as you step out on the balcony and look across all that you've built, what are you most proud of?
I think what we eventually care is that users adopt the, I'll say, new way of thinking, but it's based on others' work as well, to make it like industry standard. So if one day we can make such that you no longer treat the data you store on a computer or anywhere as files or as objects, let's call it, or when you send images to your friend, like you don't have this long span where you have to wait how each image by each image it gets uploaded to Facebook servers and then gets downloaded to the other, then we can be proud of. So if we can make sure that the way we think about the data, it becomes industry standard, and we call it data 2.0, if everyone starts using data 2.0, then I think at that point we can call it, we did our job well, and we will be proud of it.
Well, let's flip the script a little bit. Tell me about a mistake you made and how you and your team responded to it.
Well, of course, as any startup, we do a lot of mistakes. And one of the initial mistakes is that, or kind of dilemmas that we had to balance, is how we treat open source users versus the customers who are paying us. And initially, we were like struggling with this question, okay, open source users have different needs than the enterprise users, and how we can keep the balance that, of course, the enterprise users should be happy so that we can have the business going forward, but also we want to get adoption and long-term game. That's why we need open source users. One of the insights, I'll say, like the learnings that we learned is the speed to get back to the users. It doesn't matter if they are free or they are paying. Initially, we were not doing that, and we got a lot of deactivations. Some people tried the product and they didn't leave any feedback, so we didn't learn anything new there. But once we changed this behavior internally in our team, we got a lot of demand. And if you go into our Slack channel, our users post issues and feedback and feature requests 24 hours around. I mean, because they are all like different locations, it also like brings a lot of responsibility as well to be able to accommodate this demand and be able to reply the issues. And what we all started to notice is that one user posts an issue and the other user replies with a solution. So building the engine for the community is very important. And that's like one learning that we learned from the mistakes that we did. We are in a very early and embryonic phase where we had to actually work on the community and help the community to grow, to be able to sustain and enforce everything. And that's one of our next challenges. Is we got a great kickstart, but we have to make sure that the users are satisfied and happy, and in long term they will be with us.
As you look forward to those next challenges, what does the future look like for your product and for your team?
The short-term step is basically we build a community, grow the open source, and make sure that we become the industry standard for storing and managing large data sets. On the product side, in terms of the enterprise features, we are focusing on active learning tool, so leveraging the open source that we have built. And the active learning tool is not only storing and managing the dataset, but also training and deploying those models into production for customers who have plenty of unstructured data. We want to build the operating system for machine learning and deep learning, and you can think of it as like cloud for AI, but that's like long-term vision, and we are getting there step by step with the resources that are available.
Let's switch to you. Who influences the way that you work, be it a CTO, CEO, architect, really any person? Name a person that you look up to and why.
Yeah, it's difficult to come up with a single person. Of course, our team. There are so many things I also learned from the team. The team members include like Mikael, Eduard, Abhinav, David, Christina, and other also team members as well. We also have investors and advisors who are helping us a lot, especially Charo and Suman, and also like SmartGate VC. I'm also thankful to the YC team and YC, especially YC open source team, that we are like having meetups with open source developers to be able to figure out what are the issues and challenges. But it's very hard to me come up and say, okay, here's the person, I really admire him and I'm like trying to copy. Or of course there are also a lot of kind of competitors and call them as well friends that are important to gain their knowledge and gain their insights about the market and how the trends are moving forward. And of course my advisor as well, Sebastian Son, who is currently the president of AI at Samsung. I learned a lot while I was working at Princeton from him.
So, we talked about mistakes, but this next question is less about mistakes and more about things that you might do differently. So if you could go back to the beginning, what would you do differently, or where would you consider taking a different approach?
Yeah, that's a pretty tough question. So this is given like, okay, you have done all these mistakes, given the information and given the insights that you gathered, where would you start from in the beginning? I think when we started, we were very tech focused and thinking about the technology too much and less about the users. And maybe we are still doing that. So at the very, very beginning, while I was at Princeton and doing the PhD, I would, before even applying to YC, I will definitely try to get more user validation of the product that we are building, and not only user validation, but also like business validation. Basically, if this is something that companies will pay for or users will pay for. Though sometimes it's very tricky, especially when you have a deep tech company and you need to get a technological innovation to be able to prove that, but then you also have to minimize the business risk once you have this product, will the users or will the customers will get that and buy that? I think that was one of the initial things that I wish I had more knowledge or experience with before jumping into the startup journey. There are multiple ways of startup succeed. The first one is that you figured out the product and you get a PMF and then you are scaling the company. And that's the best location you want to be. And on the other hand, it's kind of a journey. You try a lot of stuff, you do a lot of learnings, and then you come up with a product iteratively and get to the PMF. I think that's the case. The second is the case with us. So we are still in the journey basically to get to the product market fit, though we have so many already assumptions validated, and there are last pieces left to validate and grow the company to the next stage.
Well, last question, Davit. So you're getting on a plane and you're sitting next to a young entrepreneur who's just built the next big thing. They're jazzed about it. They can't wait to show it off to the world. They can't wait to show it off to you right there on the plane. What advice do you give that person having gone down this road a bit?
There are 3 things that I would like to know about it. First of all, is there something that this person is really passionate about it? Even if it works, a lot of people are using it. Is this person really passionate about it? Second thing, if this person can be the best at it in the whole world. And third thing, even though it could be the most innovative technology, is it something other people need and use? So if I get a satisfied answer for 3 of those problems, then unfortunately I don't have anything to add there. But if I feel like basically there's less passion there involved, or maybe it's just it's very difficult to figure out the business model for the product that he has spent so much time on, I will just basically advise what he tells is just launch it as soon as possible and see if the users need it, instead of spending a lot of time and building this internally inside backyard of your house.
That's great advice. Well, Davit, thank you for being on the show today. Thank you for telling the product creation story of Activeloop.
Thank you very much, Noah, for inviting and having me here. And really thanks for the nice conversation.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. Support the show on patreon.com/codestory for just $5 to $10 a month. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.
What's the difference between DIY and doing it yourself? It's the difference between a part-time passion and a full-time business. Wix gives you the power to turn your passion into a moneymaker. With a website that fits your unique vision and the business tools you need to succeed. Let your ideas flow with AI that guides you, but keeps you in the driver's seat. Manage your business from one dashboard and keep it growing with built-in marketing features. It's time to turn your daydream into your dream job. Do it yourself. Go to Wix.com.